Before we take a look at any of the distance and displacement, let's just analyze what's happening with vectors. So I'm starting at position 2, I end up at position 4. So I've drawn this little vector from 2 to 4. Vector here, I just mean a little arrow. It shows that I walked 2 meters east or to the right. Okay. Next, I'm going to show that I'm walking from 4 meters to 0. So that's why I've drawn this green arrow, the length from 4 to 0. You'll also notice that this green arrow is west. It's to the left. So I'm going to go ahead and put a little negative symbol in front of that. Whenever I am calculating the distance of something, I'm going to look into just the absolute values of it without looking at direction. So I'm going to have 2 meters plus negative 4 meters, absolute value, and that means that I'm going to have a total of 6. When I look at displacement, I do take into account the positive and negative values. So here I'm going to have positive 2 and negative 4 to give me a displacement of negative 2, because the 4 was pointing to the west and to the left. From t equals 0 seconds to 2 seconds, I have no rise. And I have a run of 2 seconds. I have no slope. Remember that the slope represents the velocity in a distance time graph. From 6 seconds to 8 seconds, it looks like my graph went down a position of 4 and over 2 spots from 6 to 8. So I rose negative 4 and my run was 2 seconds. So that my slope is negative 2 meters per second. When I'm trying to find out the average velocity, it's going to be displacement over time. And so I've calculated my displacement here in number 2. What's my displacement from 0 to 8? From 0 to 8 is negative 2 meters. So that means I can go ahead and just plug in negative 2 meters, because that's my displacement. Displacement, remember, is also delta x, final minus initial. This was your final. This was your initial. Your final was at 0 meters. Your initial was at 2 meters. So that your displacement comes out to negative 2 meters. So that matches. And then your time was 8 seconds. So that our final answer is going to be 1 over 4. The same thing as 0.25 second negative. When we take a look at number 6, for the velocity of object A, we can look at the slope. The slope is going to tell us the velocity. So let's see, how much did we rise? How much did we run? We rose from 0 to 4. So this would be your y1. This one's your y2. So we would have 4 meters minus 0 meters. In terms of run, we went from 0 to 8. So this would be your x1, x2. So that would be 8 seconds minus 0 seconds. So that your velocity for object A is basically rise 4, run 8. or also 1/2. Next, they ask us about the velocity of object B. This is object B in blue here. So we can find out how much did we rise and how much did we run. So we rose from 4 to 6. So that's a rise of 2. How much did we run? Again, we went 8 seconds. So the velocity of B would be 1/4 meter per second. If we take a look at this in decimals, it makes it a little easier to see which number is bigger. Because our position also tells us the location of something with respect to 0, we can say that the farthest object, or anything on the y-axis, is how far the object moved. So if we're looking at object D, how far did it move? It went from a position of 8 to a position of 0. So it went 8 meters in 8 seconds. What is the displacement in 8 seconds? Well, it went backwards, because instead of starting at 0 and moving forward, it started at 8 and moved to the left, also to the west. So the displacement would just be 8 meters negative, or 8 meters west, or 8 meters to the left. For the next question, we're looking at which object is moving the fastest. So the object that would have the biggest slope is the one that's moving the fastest. So C has no slope, so it has no speed. We said that object B has a velocity of 0.25. Object A has a velocity of 0.5. The only one that we don't know is D, so let's go ahead and take a look at that. So we went up, we went down 8 and run 8. So our slope is -8/8, -1 meters per second. So of all the objects, D has the most slope. So most slope equals the fastest. When solving word problems, you must memorize your units so that anytime you see a meter, you recognize it as length, kilogram as mass, seconds as time. In this case, distance is our length, so the letter is just D. So let's go ahead and take a look. A rabbit can cover a distance of 80 meters in 5 seconds. 5 seconds represents time. So if I want to calculate my speed, my formula is distance over time. So I'm going to go ahead and say 80 meters divided by 5 seconds. My answer is 16 meters per second. In the next one, I have 50 seconds. So that's going to be time. And I have meters per second as a combination. So this must mean that this is my velocity. And what I'm looking for this time, how far is a distance. For this one, I recommend that you use this little triangle, D dollars on top. So if you're looking for distance, your formula is T times V. So that means that when I substitute, I'm going to have 50 seconds, velocity 25 meters per second. And so that's going to give me something like, it's going to give me a distance of 1,250 meters. If I'm looking for time, my formula is going to be distance divided by velocity. So I'm going to look for where I see meters by itself, so that's distance. And careful when you see meters that it's only meter. Like in this case here I see meters, but look ahead, it says per second. So that means this is velocity. So I have 5,000 meters divided by 240 meters per second. And that's going to give me a time of about 20.83 seconds. I noticed many of you had trouble here from 15 to 17 as well. Let's go ahead and take a look at the quantities that we have. I'm going to color code like this. When I see average velocity, I'm going to highlight that in green. What was the average velocity? What is the average velocity? What were the average velocities? Okay. If I see final velocity, I'm going to highlight in yellow. In 15, I see final velocity of 40. From rest to 38 meters per second, so that's a final velocity. A plane accelerates to a final velocity of 240. Okay. Next, let's see, anytime we see initial velocity, let's highlight that in magenta. Starts from rest. Starts from rest means initial velocity is 0. Next, from rest. What were initial velocities? Okay, so I don't know what that one is yet. Next, let's look for time. So anytime I see seconds, 5 seconds, 11 seconds. And lastly, let's go ahead and take a look at distance, displacement, okay, in x. So in the first problem, how far did he travel? Traveled 1,400 meters down. Okay, so let's go ahead and use that to solve this. So in the first problem, they're asking us for average velocity. You'll notice I have two formulas. Which one am I going to use? It looks like, okay, so I'm looking for green. Both of these have green. And it looks like I have pink and yellow. Pink and yellow. So I have everything for this formula. So that's what I'm going to go ahead and use. So let's see. Average velocity equals final velocity yellow, 40 meters per second, plus pink velocity, which is 0, which was my initial, all over 2. So my answer, it looks like 40 plus 0 divided by 2, 20 meters per second. Let's go to the next problem. So they're asking me what was the average velocity. So that's those two. And they also want to know how far did it travel. I have time, I have yellow, I have initial. Okay, so don't have this one. Let's see. So if I multiply my average velocity and my time, I can get my distance. Oh, but they're saying, what was the average velocity? Well, it looks like in this case, I have two unknowns like this. Unknown, like that. So if I try to use this second formula, I have two unknowns. That's bad. I can't solve anything with that. However, I can solve using this one, because I know most of the things in here except for one thing. So let's plug in what we have. We're looking for average velocity. I have my final velocity, which is 38. My initial velocity, which is 0. This is a plus symbol. and my time, which is 5 seconds. Okay, so let's go ahead and take a minute to calculate that out. Looks like my average velocity is 7.6 meters per second. Now I can use this number and plug it in here. So to solve my last one, which is orange. So I can say 7.6 meters per second is going to equal my orange unknown divided by 5 seconds. And I can multiply these two in order to get my distance. So 7.6 multiplied with 5 is going to be 38. So that my distance is 38 meters. So in this last problem, I have to figure out the average velocity and the initial velocity. I have my final velocity, but I don't have my initial velocity. I don't have my average velocity, so I can't use that formula. I do have time and I do have distance, so I can figure out my average velocity. So let's go ahead and plug that in. So we're going to have 1,400 meters divided by 11 seconds. And let's go ahead and calculate that. So that gives me 127.27 meters per second for my average velocity. So now I have this one, have this, and now I am left solving for my initial velocity. So what I'm going to do is 127.27 equals my final velocity of 240 meters per second plus my initial velocity that I'm looking for divided by 2. So from here it's just algebra. In order to move my 2 to both sides, I'll go ahead and multiply by 2. So I'm going to end up with 254 is equal to 240 meters per second plus initial velocity. So all that's left to do next is subtract. And we get an initial velocity of 14.